Hello and good day. In pre-algebra, we're covering CO26, identifying what is a function. We've talked about domain and range of functions, and now we're just going to kind of name it and visualize it. So a function is a relation, and that's a word that we first saw in PO24. What is a relation? Maybe it was CO25, but what is a relation, Aiden?
Something that relates to something?
Kind of, yeah. It's how an input relates to an output, right? It's basically a collection of ordered pairs, either as a function table or in a graph. But it shows the relationship, okay, of those inputs to outputs. So a function is a relation for which every x value has exactly one corresponding y value. Okay? A relation for which every x value has exactly one corresponding y value. Or for which every input, right, because x values are the input, has exactly one corresponding y value, which is also called the output. Okay? So down below, skip that key point for just a second there. Down below, I've got some examples, 3 examples of functions and 3 examples of not functions, okay? So going back to our definition, which is a relation for which every x value has exactly one corresponding y value, if you'll notice in this first xy table that I've labeled a function, the x values are 2, 5, 8, and 4. And what I'm saying is that every x value is exactly one corresponding y, is that when x is 2, y is 9. That's it. Nothing else. Okay? When x is 5, y is 10. When x is 8, y is 10. And when x is 4, y is 18. Which is not the same as an example of an xy table that's not a function. What's different about the xy table, this function table here, in the not function section versus the one that is here, Aiden?
The x's and the y's do not have exactly one on the non-functions.
What do you mean by that?
Like there's 9 repeated in the y section and -2 repeated in the x section.
Okay, and the only one that we care about to determine a function is that x column, right? Because it only says which every x value has exactly one corresponding y. Aiden brought up the fact that 9 repeats here in the y column. That's okay, because when x is 0, it only equals one thing, 9. When x is 3, even though it also equals 9, that's still only one corresponding y for the x value of 3. Where we run into a problem, though, is that when x is -2, y is both 7 and 10. Right? There's more than one corresponding y for the x value of -2, which breaks our rule of what a function is. Okay? The next one over there, how many different y values are there for the x value of 1? How many y values are there when x is 1 in this second table here, in the not function section? Okay? How many y values are there for the x value of 1? Yeah. 3, right? When x is 1, y is 6. When x is 1, y is also 10. And when x is 1, y is also -9. That's why it's not a function. Okay? Versus this table here, when x is 1, y is 6. When x is 8, y is 10. Even though y repeats itself, it all depends on how many, it's the y value that corresponds with the x. X is different, 8, 10, 9, 10, that's okay. Then when x is 12, y is 15. Back up here, I kind of like to explain it, relating it to birthdays, okay? Is it okay for 2 different people to have a birthday on the same day? Do you know of any other student in the school that shares the same birthday as you do? A teacher, okay? And that's okay, right? That's kind of what's happening here. Okay? If you're person 8 and that teacher is person 9, it's okay for two different people to have a birthday on day 10. That makes sense. That does happen. That's like what a function is. But it's not okay, it doesn't happen for the same person to have a birthday on 2 different days. As awesome as that would be to get presents, more than once a year for your birthday, that's not how it works. You're born on one day, right? So if you're person -2, you can't be born on both day 7 and day 10. It doesn't work like that. Not a function. So when we talk about, every x value is exactly one corresponding y, think of birthdays, okay? Every person has one birthday, right? And 2 people can have the same birthday, such as we see here. But it's not okay for the same person to have 2 different birthdays. Anyone want to challenge that? In now 14 years of teaching, I've never, ever gone through this lesson without somebody raising their hand and try and prove me wrong on that. No? Aiden?
I have a question.
Okay, go ahead.
Would it be okay if, say on the non-function, if the -2, they both equal 10 and they were on the same chart?
That would just be the same point. So yes, the same point listed twice. Aiden's asking, well, if this 7 were a 10, so you have -2, 10, and then -2, 10 again later on, will that still be a function? Yes, because it's just saying that it's repeating the same point. Okay. No one wants to challenge about what if you're born 11:59 p.m. end at midnight, you cross over. No one. More proof this is the quietest class I've ever had. Okay, all right. So the other type of way we can represent a relation is in a graph. Okay, and so I've got an example of a graph in the function section, an example of a graph in the not function section, and there's something called the vertical line test. It's abbreviated VLT, vertical line test, which is a way to determine whether or not a graph is a function. And if you'll notice here, I can put vertical lines through this graph in several different places, but each vertical line that I draw only touches the graph one time. Okay? When x is, what is this, 7 or 6? When x is 6, y is only 6. Okay? When x is -1, y is only +1, right? It only touches the graph one time. Whereas in the second one, where it's not a function, if I put a vertical line here, well, it touches the graph in 2 different spots. That's because in this example, when x is 3, it looks like y is both about +2 and about -2, right? The ordered pairs, not -3, the ordered pairs 3, 2, and 3, -2 are both on the graph. 3 can't be both 2 and -2 for it to be a function. Okay, this is the only time that we mention graphs, just in this little section here, just to introduce it a little bit. In algebra next year, we'll go a little bit deeper, but there's kind of your intro to it. Okay, questions so far? Okay, down below. It says, which of the following are functions? Explain how you know. Is that first XY table, that first table, a function? Raise your hand if you think, yes, it is a function. Raise your hand if you think, no, it's not a function. There are a total of 4 people who raised their hands for either of those things. It's either a function or it's not. I want everybody to make a commitment, even if you're wrong. Pick a side. Raise your hand for function. Raise your hand for not a function. Ooh, about split, half and half. Well, if we look at this here, okay, we've got an x value of -1, And when x is -1, y is 5. Are there any other y values when x is -1? No. When x is 0, y is 5. Are there any other y values for when x is 0? No. When x is 1, y is 5. Okay? And if you said this was not a function, you probably saw these 3 5s here and said, ooh, that's a lot of repetition there. Can't be a function. But remember, what this is saying is that 3 different people all share the same birthday. That's fine. There are 3 different x values here that all have a value of 5, but that's okay because x does not repeat. We don't care what y does. Okay? We're looking at those x values. If x repeats, it is not a function. And -1 and +1 are different values. Okay? They're in different spots on the number line. So yes, this one would be a function. And the reason why is because x does not repeat. Okay? How about the second one? Raise your hand if you think it is a function. Raise your hand if you think it's not a function. That's better. Yes. The same person can't have 4 different birthdays. Like I said, as much fun as that might be, it doesn't work like that. When x is 3, y can't be 6, 7, 8, and 9. So no, not a function. And the reason why is that x repeats. Third one, function, yay or nay. Raise your hand for yay. If you're unsure, look at that x column. We don't care about y. Look at that x column. Does x repeat? Okay, it does not. So you yay people, you are correct. It is a function. Again, because x does not repeat. Okay. Aiden.
Could there ever be a case where x does repeat and it's still a function?
No. No. The only thing is what you brought up earlier, where if the same ordered pair is listed twice, but then it's the same ordered pair. But if there's ever a case, there's no exception to where the same x value equals 2 different y's, it's not a function. Okay. 3 ordered pairs. First word problem here. 3 ordered pairs of a relation are 4, 8, -3, 6, and 5, 10. Write a 4th ordered pair that will make the relation not a function. Okay. There are several different answers to this. Infinite number of answers to this question, actually. Who would like to raise their hand and give us what they have? An ordered pair that you can add to this relation that would make it not a function. Currently it is. What would make it not a function? Aiden?
6 and 1.
6, 1 would keep it a function because I'm looking at my x values here. 4, -3, 5. 6 is different, right? So 6, 1 would keep it a function. What's one that would, yeah. 5, 2 is a possible answer, right? I've repeated the x value of 5, therefore it's no longer a function. 4, 12 is another possible answer. Repeating the x value of 4 would make it not a function. -3, 9. Repeating the x value of -3 would make it not a function. You see why there's an infinite number of answers here, because you could do 5, 2 or 5, 3 or 5, 4 or 5, 5 or 5, 6 or 5, 7, right? As long as you repeat one of those x values, it is no longer a function. The next one, 4 ordered pairs of a relation are 0, 6, -2, -5, 3, -5, and -2, 4. Which ordered pair should be removed to make the relation a function? So as it's written, it is not a function. Which ordered pair should be removed so that it is a function? Okay. -2, 4. If that's gone, our x values, 0, -2, and 3, no longer repeat. Is that the only option? What else could we remove? Somebody I haven't heard from yet today, perhaps. Okay, Aiden. Oh, Sasha, sorry. Go ahead, Sasha. Right, the other x value that repeats, -2, -5. Okay, you don't want to remove them both, right? But one or the other would make our x values legit. Finally, a game show has you randomly select a number. So here we're looking at functions in a different context here. A game show has you randomly select a number that corresponds to a prize. If you select 4, you get a puppy. If you select 7, you get a scooter. If you select 11, you can choose between a taco and a trip to Hawaii. I think we all know what we're going to pick, the taco. Yeah. Does this situation represent a function? Why or why not? Does this situation of you choosing a number and then getting a corresponding prize represent a function? Why or not? Sarah? Okay. Aiden?
No, because there's a y, because you can only have like one number for one x, and there's two things for one x value.
Okay. And when you say there are two things for an x, what are you talking about?
Like if you select number 11, you can get either a taco or a trip to Hawaii.
Okay. Any other thoughts? If we were to kind of draw this out as a function table, that can be helpful here. So I'm going to give myself a little more space. Okay. If we were to draw this situ out as a function table, we'll call the number that you pick x and the corresponding prize y. If you select 4, you get a puppy. If you select 7, you get a scooter. And if you select 11, you can either get a taco, or for number 11, you can get a trip. Okay? And when you map it out like this, it becomes very clear that this does not represent a function, because that x value repeats itself. Okay? For the value or for the number 11, it's not just one corresponding prize. You get a choice. You see the connection there? Does that make sense? Okay? All right. So your homework is going to be on the Google. It's a Google quiz. It's not posted yet. I will do so as soon as we sign off here. It's a 6-question quiz, a review of CO24, CO25, and CO26, what we just covered here. As with all of them now, you must get 100% on it. So you can use your binders, use your notes. If you don't need them, great. But if you do need to check back, then feel free to do that. So that's the only homework for tomorrow, the Google quiz, posting Google Classroom shortly. That is how you math. And click the link.